Dear all, welcome to my YouTube channel, and today I will be discussing about the tree concept in data structures. So this is the outline of the points that will be discussed in this short video on tree concept in data structures. A tree is a hierarchical abstract data structure. Now when we use the word tree, there are certain words related to tree which comes to our mind like root, subtree, branches, stem, leaf, right. So these are the words which will be part of tree data structure also. So we have tree as a hierarchical abstract data structure which has the one element as the root and other elements are the subtrees of the root element. Okay. So a tree is nothing but a non-linear data structure which is set of one or more nodes where one node is considered as the root node and remaining nodes will be divided into subtrees of the root. Okay, a tree which doesn't have any nodes is also called as null or an empty tree. Now there are various basic terminologies or the related words used in the tree data structure. Like as I said, when we say tree, we come across certain basic words like root, stem, leaves, branches. Okay. Similarly, we have certain terminologies used in the tree data structure which are called as root, parent, subtrees, siblings, descendant, ancestors, leaf nodes, and so on. All these terminologies can be best explained with the help of this diagram, with the help of this tree structure. So as you can see here, we have a tree structure, okay, in which the node A is the root node and remaining nodes B, C, D, E, F, G, H, I, J are divided into subtrees of that root node. B, C and D form the subtree of root node A. E and F form the subtree of the root node B. G and H form the subtree of the root node D. And I and J form the two children of the node H. Now, in this diagram, what we observe is node E, F, G, I and J are the leaf nodes. Leaf nodes means those nodes which are further not divided. Okay? They are called as leaf nodes or terminal nodes. Then E and F, they are sibling nodes because they belong to the same parent B. I and J are the sibling nodes because they belong to the same parent H. Now, each tree has levels. When we start from the root is at level 0, B, C, D are at next level 1, E, F, G, H are at level 2 and level 3 represents I and J. It is also called as depth. It is also called as depth. Now, looking at some other terminologies like A is also called as parent node or ancestor node and B, C, D are the descendant node which are the successor nodes of A and so on. So A is called as ancestor or predecessor node and B, C and D can be called as successor or child or children nodes and so on. Okay. Now to represent or to define a tree as a data type, then we consider a root node and two parent nodes. And to confess finite trees, the list of children node should either be empty or it should have a permanent size. Permanent size means the branching factor should be equal to 2. 2 means binary. Binary by means 2. And as a data structure, a tree is a group of nodes where each node has a value and certain references to its child or children nodes. Like in this diagram, we can have node A as the root node, and then we have B and C as its children. Now if you look at node number B, it has 3 children, D, E and F, which are also termed as sibling nodes because they have the same parent B. So now this part B, C, B, D, E and F, this is my subtree and it is linked. Okay, so each node has a value and a set of references. Binary tree can be represented using an array representation as shown here. Now as we know, tree traversal. Tree traversal means visiting every node of the tree at least once. Okay, stepping through the items of a tree distinctly of the connections between the parents and the children is called as traversing a tree or walking a tree. Now there are 3 ways in which this traversing happens: pre-order, post-order and in-order. Pre-order traversal is one in which each parent node is passed through before its children. Post-order is the walk in which children are traversed before their parents. And the in-order is the walk in which a tree is traversed in a sequence, followed beginning with left subtree, then the parent node itself, and then the right subtree. Then there is also called as level order walk, where the nodes are traversed level by level, starting from level 0 coming to level 1, 2 till the leaf node, till the last level. So nodes are traversed level by level, where the root node is visited first, followed by its direct child nodes and their siblings, followed by its grandchild nodes and their siblings, etc. Now there are various applications of tree data structure. It is used in many applications, few of which are listed here, like in game development. In game development, a tree is used to attain levels. Now as we all are aware, whenever we play games, there are various levels of the games. Okay. So various levels of the games are represented using the node of a tree. As we move one level ahead, we move from level 0 to level 1, level 1 to level 2. It is represented as a tree. Then tree is also applied in machine learning algorithms. Machine learning is nothing but making the computer intelligent enough to predict some things. Like in this diagram or in this chart, we can see we are trying to make machine intelligent enough so that it can predict whether the weather is sunny, rainy or something else. Now these prediction based analysis can be implemented or can be represented using a tree-like structure. This will help better in prediction analysis. Then tree is also used in our day-to-day life, where we are more focused on desktop PCs, okay, where we keep our data in various folders, from one folder to another, from another to another, and so on. For example, we take one folder, say data structures, and in that I make subfolders, say tree, then second subfolder, say stack, third subfolder, say queues, and so on. And then I store data related to stack in the stack data structure, stack folder, data related to queue in the queue folder, and so on. Why this is done? This is done so that I can search my data easily. My data will be available to me on easy basis. So this subfolder representation is done using tree. Similarly, tree is also used to represent various data in companies, okay, where you can store details of various employees and their personal details, their professional details, and everything can be represented using an hierarchy. These are some of the other applications of tree data structures. I hope you liked the video. Thank you.